Good morning, everyone. My name's Mike. I'm the manager of the Buhl Planetarium at Carnegie Science Center, and I'm pleased to join you for an edition of Bite-Sized Buhl. This morning, we're going to give you a taste of what you can experience on site in the 50-foot newly renovated Buhl Planetarium at Carnegie Science Center. And right now, we are celebrating ancient Roman mythology and the stars over the city of Pompeii. I'm very excited that this Saturday, Pompeii the exhibition will be opening at Carnegie Science Center. It's a chance to step back in time and understand the ancient Roman world. And today we're going to look at the stars, not as they appear this evening, but as they appeared on the night of August 23rd in the year 79 AD, or 79 CE of the Common Era. So we're stepping back in time about 2,000 years, and that's what we're looking at right now. This is something you can actually try at home. I'm using a free software called Stellarium. You can download it on your computer or cell phone and actually travel back in time, which is something that we're doing right now in Buhl Planetarium, putting together a new program that will debut to celebrate the astronomy of Pompeii that's opening this weekend. But if you look at our digital star clock here in Stellarium, you can see what the ancient Roman citizens saw on this night. And I picked August 23rd, 79, because the next day, the city of Pompeii was destroyed by an eruption of the nearby Mount Vesuvius. But while the city was destroyed, the volcano also preserved its history, its heritage, under layers of volcanic ash. And now through modern archaeology, through painstaking work, all of that has been brought back, as it were. So while volcanoes destroy, they also have preserved for us this snapshot in time of ancient Roman life. So we'd like to share with you what the citizens of Pompeii saw in the year 79 AD. And they celebrated the planets. They saw a parade of planets marching across the sky, which they associated with their gods. And the major planets still carry the names of Roman gods today. They saw all of these as divine lights wandering through the sky. They didn't distinguish yet between planets and stars, but they saw a whole pantheon of planets marching through the evening sky. The time is about 8 p.m., August 23rd in the year 79, and you can see the moon in our night sky, known to the Romans as Luna. And following the moon in the early evening sky was the planet Saturn, the god of farming and agriculture and growth. But we're going to step through quickly the evening sky and see what other planets we can find. As we move through the evening in the southeast, you might see the fiery red Mars appearing. Now, Mars, we know today, is red because of iron oxide. It's a rusty planet, but it looks fiery in the sky, and it was associated with the god of war. Here we are at almost 2 a.m., and Mars is in the south. As we keep moving through the evening sky, we can see that Jupiter was shining brightly. Here we are at almost 5 a.m. the next morning. Jupiter had ascended to its full glory by midnight. Jupiter is the largest planet, and for the Romans, Jupiter was the god of sky and thunder. And then rising very close to the sun, we can see the planet Venus. This was named for the goddess of beauty due to its bright appearance in the sky. And Venus was seen as the patron and the protector of Pompeii. And then we return to the sun the next morning, who the ancient Romans believed would have been carried up into sunrise by Apollo's golden chariot. The sun was brother to Luna the moon, Sol and Luna. So that's just a taste of what the citizens of Pompeii in ancient Rome would have seen. Even though there was a mountain looming over them, they set their sights higher to the sky, and they placed their gods in the sky and made meaning out of the stars. And even today, the constellations and the planets that we see all carry the names of this Greco-Roman heritage. But now we're going to take a look at Pompeii from a different perspective. So we've looked up into the sky, as the Romans would have. Now we're going to switch over to different software. This software is known as Digistar, and this is the engine that runs the Buhl Planetarium at Carnegie Science Center. We're going to take a different view of Pompeii from outer space now, looking back at our home planet Earth. And we're going to start by zooming in on this ancient city. It's located near modern-day Naples, and you can see the boot of Italy very clearly from space. And let's zoom in. All right, so over on the left of your screen, you'll see the Bay of Naples, and you'll see the towering Mount Vesuvius in the center. And just below there is where the ancient city of Pompeii would have been. There are 3 million people that actually live in the vicinity of Vesuvius today. But it's the most closely monitored volcano on the entire planet Earth, arguably. We have a lot of early warning systems in place to know if Vesuvius will erupt again. On the ground, we have dozens of sensors that record seismic activity, the temperature of the gas that's emitted by Mount Vesuvius, and any rises or falls in the land, any changes in topography that might indicate there's magma, molten rock moving beneath the surface. There are even flying drones in the air that use miniature gas sensors and spectrometers to collect data. All of this data is sent to the Vesuvius Observatory, which is over to the west in Naples on your screen. And the European Space Agency even has a dynamic duo of Sentinel satellites that pass over, take data from not only Vesuvius from space, but actually measure volcanoes all around the world to help countries with early warnings from space as to what might be going on. We're going to zoom in a little bit closer on this mountain. Vesuvius is known as a stratovolcano. It's about 4,200 feet tall. Another way to think of it would be, if you live in Pittsburgh, the U.S. Steel Building downtown, stack up about 5 of them, and you'll get to the height of Mount Vesuvius. And you can see the caldera where it erupted in the center, with a huge plume of volcanic ash and smoke that rose into the stratosphere. We've zoomed in here. You can actually see some pathways up at the top of Vesuvius. And as we hit our mark here, I'm going to back us out a little bit so we can get a better view of the caldera of that central crater where Vesuvius would have erupted. Now, the cool thing about Vesuvius is it is actually a volcano inside an older volcano. In the center of your screen, you can see the caldera where it erupted, but just above it, you might see on the north ridge a remnant of a larger crater from an even taller prehistoric volcano known as Mount Soma. That was even taller. When it blew its stack, the entire mountain system, the top blew off. It became smaller, and Vesuvius is formed out of what's there. All right. We're going to head back out to space, because Vesuvius is just the start of our adventure today. Vesuvius is part of a cluster of volcanoes that we see in the northwest region of Italy. And that's because Italy lies on a fault line. If you think of the Earth as having many large slabs of rock that are moving around over the mantle. So our rocky crust is moving around over molten rock underneath, almost like plates, tectonic plates. They're almost like a cracked eggshell. And these plates, as they slide past each other or crash together, that's when devastating things can happen on the surface. Earthquakes, a lot of volcanic activity lines up with fault lines. And Italy is very close to the boundary of the African plate and the Eurasian plate. So as one plate starts to slide down underneath the other one, that causes magma to be forced to the surface. All right, we're going to head off, though, from Italy to another country that lies along the location of two tectonic plates that meet. And we're going to move west from mainland Europe over to the country of Iceland for our next volcano. Here you can see Greenland, just the southern tip of Greenland on the upper left of your screen, covered in ice. And right in the center, you'll see the nation of Iceland. Below it, you'll see some cloud cover. You might see England and Ireland in the lower right of your screen. But right in the center, we have the nation of Ireland. Now, Iceland, emerged from the Atlantic Ocean because in this case, two plates are spreading apart, the Eurasian and the North American plates. And Iceland spans what's known as the Mid-Atlantic Ridge, and volcanic activity is continually forming new crust as these two plates drift apart. And they're drifting apart about a centimeter a year, so roughly about as fast as your fingernails are growing. These plates are drifting apart, and we have lots of volcanic activity here in the hotspot of Iceland. And Iceland even has its own version of Vesuvius, another stratovolcano that became world famous. We're going to zoom in on it, take a look. This is Eyjafjallajökull, and its name means Glacier of the Mountain of the Islands. Eyjafjallajökull is a volcano with an ice cap on top. It's 5,417 feet high, so that's even taller than Vesuvius. Stack up about 6.5 U.S. steel buildings if you're a Pittsburgher. And this volcano had its own world-famous eruption. This was in our recent history in April of 2010. It blasted volcanic ash several miles into the stratosphere. It disrupted air travel for actually a number of days in April and May in the northern European and Atlantic Ocean region. And the overlying glacier melted and caused flooding throughout Iceland that spring. All right, we're going to head back out into space. We're going to be traveling westward now once more. So we're going to head back out over our view of the Atlantic Ocean, and now here we are over the Pacific Ocean. Now the sun hasn't caught up with us yet, so I'm going to move the sun across our screen. There we go. And you can see we're in the Pacific Ocean over the Hawaiian Islands. Not all volcanoes are stratovolcanoes. They come in different shapes, sizes, and forms. Stratovolcanoes tend to have that perfect cone shape to them. They explode material out, often toward the stratosphere. Other volcanoes can be more effusive rather than explosive, like the shield volcanoes, shaped more like a shield that we see on the islands of Hawaii. And we're going to zoom in on just one of those right now. We're going to zoom in on Mauna Kea. Now, Mauna Kea is actually dotted by telescopes, which is why I picked this location. There are 13 telescopes funded by 11 countries that make up the Mauna Kea Observatory. And it has a proud history in science. Most recently, it's the home of the Hawaii Space Analog and Simulation, or HI-SEAS. It's a Mars and Moon Exploration Research Station, where simulations are conducted for future Marstronauts, so to speak. 4 to 12 month long simulations to try to experience the closest we could get to the environment, geology of Mars, perhaps on Earth, as this area is thought to resemble the surface of Mars. It last erupted about 4,000 to 6,000 years ago. As we pull away, we can see how lava has made its mark on the landscape from Mauna Kea and even neighboring Mauna Loa. Well, speaking of Mars, that's actually our next stop. We're going to be leaving the Earth behind. And while programs like HI-SEAS help us try to get closer to what living on Mars might be like through studies on Hawaiian volcanoes. Today, we're going to take a sneak peek at the real thing and actually travel to Mars for our next stop. We have a beautiful view of the sunlit Earth there. We can see the city lights over Europe, Saudi Arabia, and Africa. And let's set course for Mars for our first space volcano. Now, our next stop actually dwarfs easily Vesuvius and any other volcano you'd see on Earth. When the ancient Romans looked to the sky, they believed that Mars was the god of war. They saw this planet as a perfect divine light. Today we found that it's home to ancient volcanoes. It had its own cosmic cauldrons, which affected the landscape. Now, Mars is rusty red, as I said earlier, but any of the darker areas you see there, that's exposed basaltic rock from ancient lava flows on the planet. And we're going to take a look at the biggest volcano of all. We're zooming in now, and I'm going to move the sun as well to adjust. And there we are. We're going to bring the sun back. I got a little excited there. All right. So we are looking at the largest shield volcano, and in fact, the largest volcano or even the largest mountain in the entire solar system. This is the Martian Mount Olympus, known as Olympus Mons. For comparison, on Earth, we're going to move away from the steel building as an analogy. Think of 2.5 Mount Everests stacked up on top of each other, and you would get to about the height of this mountain. You can see the caldera in the center where it once erupted. But if you trace the outer edge of this mountain, you're tracing an area that's roughly the size of France. So if you were to move Olympus Mons to Earth, it would cover the country of France, which I think is pretty extraordinary. And as we zoom away, you can see it's almost in 3D there. It's a bump on the surface of Mars. It's visible from space. I think that's even more impressive considering that Mars is half the size of Earth, but volcanoes like Olympus Mons are staggeringly huge by comparison. Well, our next stop is going to be one of the moons of Jupiter. So we're heading out to Jupiter, the largest planet in our solar system, and to one of the moons in orbit. Before we do, though, one last view as we come around to the side of Mars. You can see Olympus Mons and 3 more volcanoes in a line just to the left there. That whole region is known as the Tharsis region, home to ancient volcanic activity. But let's leave Mars behind and head off to Jupiter and my favorite Jovian moon, the moon of Io. Io has 400 active volcanoes, at least. And sometimes these eruptions can even be spotted from space. In 1979, the Voyager 1 spacecraft flew by. There goes Jupiter. And here comes the moon of Io. And you can see a large orange ring. It's just going to the left out of view, but it'll be back as we orbit the moon. That ring encircles a volcano known as Pele, named for a Hawaiian god. And Voyager 1 observed a plume erupting from Pele. It rose high above the surface. It could easily spew a ton of material out into space every second. And it's plumes like these that gave Io all of these beautiful colors. The reds, yellows, oranges, and blacks that cover the moon. Those are all various sulfur compounds expelled by Io's volcanoes. And I think they kind of look like a pizza as a result. This is sort of a pizza-faced moon topped, if you will. The pizza toppings are the sulfur from the volcanic material we see. Let's come back around to that ring one more time. This again is massive in size. It's material that shot out from Pele that landed and collected nearly 350 miles away from the vent itself. That's the radius of what we're looking at. Let's come in for a closer look. There we go. Just so we can back out from the center of Pele and see how far away we're talking. That's a 350-mile radius to that ring of red sulfur compounds. All right. And our last stop today is going to be my favorite dwarf planet, Pluto. We've talked about volcanoes on Earth and in space that are fiery cauldrons, but not all volcanoes spew fire. As we leave behind the moon of Io, we're going to check out an entirely different kind of volcanic activity on Pluto. So here we go. Setting course away from Io and Jupiter. Out past the gas giants, we're heading toward a region of space known as the Kuiper Belt, where we find icy objects, including dwarf planets like Eris and Pluto. Now, in 2015, the New Horizons spacecraft flew by Pluto, and it imaged its famous heart shape feature. We're zooming in on that right now. You can see it on the left-hand side. We've come in upside down right now, but you can almost trace. We'll see if we can stop the orbit for just a moment and head back. You can almost reach out and trace the heart of Pluto. On the right side, what you see is an area known as Sputnik Planitia. It's essentially a great hockey rink in space. It's covered with nitrogen ice, a very smooth plain, and it's surrounded by mountains. Now, none of the volcanoes were erupting when New Horizons went by, but New Horizons imaged the summits of some of these mountains, and they looked very similar to summits of volcanoes on Earth. So there's strong evidence that they are volcanic. I'm going to zoom in on a couple of them now that are down near the southern part of Sputnik Planitia and the surrounding mountains. We've zoomed into an area where there's the summit of a volcano known as Wright Mons. It's named for the Wright brothers. And not all volcanoes, as I said, spew fire. You would definitely not find that on Pluto. Wright Mons is, or the mountain of the Wright brothers, is a cryovolcano. These would spew materials like ice, whether it's water ice, ammonia, methane, super cold compounds that are erupting out into space. And even farther south, right on the tip of our data, we'll zoom out for a broader view here. But we're covering a region known as Picard Mons. And that was named for a French high-altitude ballooner, Auguste Piccard. And here we are coming back out into space. We can see the atmosphere of Pluto. New Horizons went by very quickly, but it did image Wright Mons and Picard Mons. Wright Mons named for the Wright brothers, Picard Mons named for that high-altitude ballooner. Not for the captain of the Enterprise, although that's probably where the name comes from as well, that Swiss family of explorers. All right, so our journey today has taken us from Pompeii to Pluto, to Captain Picard. We're going to come back, though, to Vesuvius and the Roman Empire, where it all began. As all roads lead to Rome, let's come back for one final view of Vesuvius. That was just a taste of a few volcanoes that we're exploring in a brand new program called Space Volcanoes. It's opening this Saturday at 12 o'clock in the Buhl Planetarium at Carnegie Science Center. All to kick off Pompeii the Exhibition, which is an extraordinary chance to, I think, step back into the past and understand the life of ancient Romans and how archaeology has helped to preserve and translate that way of life for us to understand now. But let's come back to Vesuvius to bring things to a close. Here we can see, even at night, the boot of Italy. Human activity on the coast will bring some daylight up. And we'll take you back to the year 79, the ancient city of Pompeii and mighty Mount Vesuvius. Well, thank you for joining us today. We hope to see you on site sometime in the Buhl Planetarium and to learn from Pompeii the exhibition at Carnegie Science Center. My name's Mike. It's been my privilege to give you a sneak peek of some space volcanoes that we're exploring in the planetarium. We hope to see you soon, and we'll see you next Thursday morning for another edition of Bite-Sized Buhl. Get outside and enjoy the sky and keep looking up. Thanks, everyone.